New physics, new LONCAPA. Let's go. LONCAPA 1. Okay, to start, so we need to find out how to equate the entire charge of the whole semicircle. Um, and the way to do this is first, let's write our Q total. So we know that our Q total is first, it's 11.2 times 10 to the negative 6, right? Coulombs. And Q total is actually also the integral of delta Q. And why is it the integral of delta Q? Well, it's every point. Delta Q is basically saying the integral of it is every point on the semicircle added up. Every single charge, we're adding them up, right? So we're gonna actually start calling this dq from now on. Okay? And now we need to find what dq is. So on the side here, dq equals, and dq is, well, at first we know that they gave us in the thing that the lambda sign is actually charge, but our dq is charge with respect to the distance, how far it is from the middle of the semicircle. So we have that with respect to the arc length. S is arc length, remember? And we have our arc length equals our radius times theta, theta in radians. Okay, so now we also know that ds is actually, so this, we'll keep this as charge. I'll write that down actually. ds, so delta of the arc length, is the same as r times delta of the theta, okay? Because we're just changing it to follow angles now, so we still need to do it with respect to the angle, but r will stay constant. And then we know that our charge as well, as they gave us in the problem, is lambda initial, so lambda 0, cos theta, and then we keep our r, and we have our d theta, right? So now, coming back to our Q total equals delta Q, we know that it is delta Q is now this. Oops. Is that, right? But this is a definite integral, so we need to take it from the point here all the way to the point here. And what are those points? Well, they're saying theta is off the center. So if theta is off the center, that means the center is 0. So one way is negative, one way is positive. So we have negative pi over 2 and to positive pi over 2, right? So we know that Q total now is equal to that. Our sine theta is the integral of cos theta from pi over 2 to negative pi over 2, which when you do all of this, you get, we also have our Q total on the left side. So let me rewrite that down here. So then you can do all this math and plug it in. You have your radius, they give it. Make sure to convert it to meters. The only thing you don't have is your lambda, right? So if you rearrange, you'll get that your lambda, or at least mine in this case, is that, okay? And now, on to part B. So we'll do B here on the side. So all of this was A. Calculate the magnitude of the total force there, right? Yeah, sorry. So we're calculating now the force exerted if there was a charge at the center. So we know that force is equal to K, Q1, Q2 over R squared, right? But from question 1, I'll highlight this again. We remember that our charge on the circle here is going to be represented by that, right? What's highlighted. So now, and we also know, actually, before I even write anything, we know that if there's a point on the semicircle, let's say here, and it's exerting a force like this, right? Just making sure. Yeah, so it's exerting a force like that. The other one's exerting a force like that. The forces in the x directions will cancel out. It's only the forces in the y directions that occur, right? And we can see as well that the forces are going to be equal on both sides every time in the y. So we have our k, our q1. Q1 is what's given, so I'll put this here, q1. And we have our q2, which was all of this that was highlighted. Actually, I'll put the d theta out. And I'm going to move, oops, I'm going to move this a bit. Okay. And then all of that over r squared d theta. But remember, because we're looking only for the f in the, we're only looking for the f in the y component. So we also need to multiply this by cos theta. Because cos theta, if theta's up there, and we have something like that, cos theta will give us, in blue here, this y component, right? Okay, so now that we have that, we have to know as well that our force here, because we're taking the force at every point charge along the whole thing, right? So our force here is actually going to be an integral from negative pi over 2 to pi over 2 of all of that stuff, right? And now it's just straight math. So I'm going to erase on the right side here so we have some space. Right? Oh, we'll keep that. Q1. So now this goes here to k q1 lambda 0 over r. So that's all of our constants. We got the lambda, let's not forget from the first question. The integral pi over 2, negative pi over 2 to pi over 2 of cos squared theta. So let's not forget these two cancel out, and those two coses become squared, right? We can use our cos squared properties, and I'll just skip all those steps, and we end up plugging all of our numbers in here. We take the integral of that, and I end up with 773. I'll also give you the quick shortcut here. All of this is just going to give you pi over 2 most likely. So yeah,